Hello, everyone. Welcome to yet another special Glass Academy webinar celebrating the week of World Environment Day. Today, we focus on glass, an extraordinary material that has undergone remarkable transformations, positioning itself as a cornerstone of environmental sustainability. Historically, glass has been cherished for its versatility and aesthetic appeal. However, the recent advancements in glass have propelled to new heights, making it one of the most eco friendly materials available. Today's webinar honors the launch and introduction of one of the most incredible advancements in glass industry, low carbon glass. This pioneering product exemplifies the marriage of innovation and environmental consciousness, showcasing how modern technology can revolutionize materials to benefit the environment. Today we have with us Mr. Avinash Gowra, Manager Design and Residential Segment, Saint Gobain Glass India, who will launch and introduce us to this extraordinary glass product. Mr. Avinash has over 9 years of experience in the building material industry, including experience working on green rated projects. In his current role, he spearheads the design and sustainable initiatives of Saint Gobain Glass in India and implements strategies to increase the adoption of energy efficient glass in the residential segment. Mr. Avinash holds a master's degree in structural engineering, giving him a deep understanding of the building material industry and the certification process for green rated projects. And he's committed to promoting sustainability and making a positive impact on the environment through his work and personal life. Welcome, Mr. Avinash. We are delighted to have you here with us today, and we are looking forward to your presentation. Let's hear from you on the topic Shaping a Greener World, Introducing Low Carbon Glass. Over to you.
Thank you, Anvita. Thanks for the wonderful introduction. So, good afternoon, Anvita. It's indeed a pleasure to be here and represent Saint Gobain and introduce you all to India's first low carbon glass, Ore India, and explain its potential benefits and how it can contribute in decarbonizing the built environment. So, I'll start my presentation without much delay. So I've tried to break down my presentation into 5 key concepts so that it will be easy for all of us to understand. So first, let's start with why there is a need to decarbonize in the first place. And then I'll explain about the different types of carbon emissions, which is the embodied and operational carbon, and what it means to the building industry. And with that, I'll also explain what is the path to reach net zero carbon for the buildings. And then we'll touch upon the carbon footprint of facades in the current scenario and how Ore India, which is the low carbon glass, can contribute to reducing the carbon footprint of the facade and to what extent it can reduce will be the flow of a presentation. So let's begin. So if you look at the current scene and the situation it has been in the last few years, it is very evident that there has been a significant rise in the temperature. There has been floods occurring suddenly. There has been a lot of news about increase, harsh summers, heat waves on one side and the drought on the other side. And one of the main reason that is attributed to these climate events is obviously the rise in the global temperature. So we have a agreement which is made in the Paris Climate Change Agreement, wherein all the leading countries have come forward and pledged to control the rise of temperature up to not more than 2 degrees Celsius by 2100. And if you look at the recent increase in the surface temperature and how the trend has been, we have already reached somewhere around 1.2 to 1.3 degrees Celsius. And looking at the rate at which the increase has been happening, we are nowhere close to meeting the target that we have taken in the climate change agreement. And one of the key reasons for increase in this the temperature is obviously the emission of the greenhouse gases, specifically carbon dioxide. And there are models which predict that if the current trend continues, there can even be a increase in temperature of up to 4 to 6 degrees Celsius by 2100, wherein what we are targeting is only up to 2. And this calls for an immediate need for a decarbonization of the every activity that we are going to do, which is going to help the environment. And in a very simpler way, like how we need to decarbohydrate or reduce the carbs for taking care of our health, it is also necessary for us to decarbonize for the planet's health. So with this being said, let's try to understand what a carbon footprint is. So carbon footprint is basically the amount of greenhouse gases and specifically carbon dioxide emitted by a activity. That activity can be a production of a product, it can be a construction of a building, or it can be a transportation of good from one point to another point during any given period of time. And why is it important for us in the building industry to be so much concerned about this? If you look at the recent data, a survey says that out of overall greenhouse gas emissions that is happening, close to 39% of that greenhouse carbon emissions or the global carbon emissions is coming from the building sector, which is an alarmingly higher number. And even important fact to note is that 67% of India is still to be built. So, which means if we continue to build the same way, then it is going to be highly unsustainable and it is not going to yield any good result for the environment. And with that being established on why it is important to decarbonize, let's try to understand what are the two different types of carbon emissions. If you look at the emissions that is being contributed from the building sector, which is around 39%, currently a recent survey says that 72% of that is from the operational carbon and 28% is from the embodied carbon. I'll explain what operational embodied carbon in the upcoming slides. And if the with the current practices, with the current adoption of high performance materials, with the current design practices, there has been a significant work in reducing the operational carbon. And if this trend continues, what the estimate says is by 2050, of the overall carbon emissions, 50% will be from the operational carbon and 50% from will be from the embodied carbon. So this makes it very clear that it is important to reduce and work on reducing the operational as well as the embodied carbon. Now, so like I mentioned, what is operational carbon? Operational carbon refers to the carbon emissions produced during the operation and use of a building or infrastructure over its lifetime. For example, it can be a carbon emissions that is happening because of air conditioning running during the day. It can be because of the water heater. It can be because of the lift that is being operated during the use of the building. So, like in a very simpler way, it includes energy consumption for heating, cooling, lighting, ventilation, any other activity necessary to maintain the facility. So all this is under the operational carbon of the building. And what is embodied carbon? Embodied carbon refers to the carbon emissions associated with the extraction, manufacturing, transportation, and construction of building materials and components throughout their life cycle. So, this basically is right from the extraction of raw material to its installation and also its end of life, which is the demolition and being dumped to the waste yard. All this is contributed into the embodied carbon of the product or even of the building. I mean, if you still feel it's complicated, let me try to simplify it further. Embodied carbon is like a down payment on your loans, which is fixed. Once it's given, you can't change the down payment. Likewise, once you have constructed the building and the embodied carbon is fixed and you can't modify or change the embodied carbon of the building. Wherein operational carbon is like the EMI, which is variable, which I mean, if I have to apply it to the operation of a building, it's like a air conditioning. During summers, you might have more emissions because of the higher usage of AC, wherein if you are in a winter season, there might be a lesser consumption of air conditioning. Hence, there will be a lesser emissions from the air conditioning. So, this is a very straightforward example, right? Now that we have seen why it is important to decarbonize, and we also understood the difference between the embodied as well as the operational carbon and how it will exist in the building also. Now, let's try to link it and understand how these two will play a role in making a building net zero carbon. Now, like I have proposed a simple framework, which is one, measure, optimize, and substitute. Like there is I mean, what we say that what can't be measured can't be reduced. Likewise, to even think about reducing or controlling the emissions of a product or even of a building, the one of the first thing that we have to do is measuring how much we are emitting and measuring what is the carbon emissions of that building. So there are multiple tools which are available, which with which we can estimate the emissions. This can be the benchmark, and those emissions can be classified into different categories like the embodied, how much emission is from the embodied, how much is from the operational, and we can try to set key performance indicators so that we can work towards reducing the emissions of those individual metrics and then see how much we are able to reduce in the future. So this is with respect to measuring and setting the benchmark. Next is optimizing. So once a building is up, and what we can do is we can try to optimize, which or maybe we can try to even reduce the carbon emissions that is happening. So here, let's try to understand how glass can play a key role in terms of optimizing the operational carbon. So if you look at a typical glass, there are three important performance parameters. First is solar factor. Solar factor basically controls the amount of direct heat that is coming from outside of the building to the inside of the building. The lower the solar factor, the lower the direct heat or the that is going to come inside. We have to rephrase it. The lower the solar factor, the more heat the glass will cut. And then we also have U value, which looks after the direct heat that is coming from which sorry U value, which is the indirect heat that is coming from outside to inside. And again, like I mentioned, for the solar factor, lower the U value, the better will be the performance. And we also have another important performance parameter, which is the light transmission, which is basically the amount of natural light the glass can allow from outside to inside. This is basically again in form of percentage. For example, a glass can have 50% light transmission, which means it will allow 50% of the outside light from inside. So, 50% the outside light to the inside. With this being explained, I'll try to explain a small case study on what is the impact of the right choice of glass on the operational carbon. So if you look at a comparison between a clear glass, which is your basic glass, which has a solar factor or SHGC, which is solar heat gain coefficient of 0.76, a light transmission of 80 and U value of 2.8. And we have tried to compare it with our high performance coatings, which will basically control the amount of light and heat that can come inside the building. If you look at this comparison, you can see that it is possible to reduce the cooling load. It is possible to reduce the cooling load, which is basically the amount of AC cooling load, by almost 35%, depending on the choice of glass we are using in our building. So by choice, what I mean is by optimally selecting the glass which is having the a good solar factor, optimum light transmission, and a lower U value. So with this, glass can play a significant role in reducing the operation carbon of the building itself. Right now, there are other ways by which we can also reduce the operational carbon, which is basically in terms of designing the building in such a way that we can have passive architecture like shading devices, which also reduces the direct heat that is coming inside the building, which also directly reduces the burden on the air conditioning. Right. So now we have seen how three out of three steps in terms of measure and also optimize. We have seen how why it is important to measure, and then we can optimize by choosing a glass which is having a good performance parameters, and then also with terms of good design, we'll be able to optimize the operational carbon. Next is substitute. Substitute is basically using products which are having lower embodied carbon emissions, like materials which are lighter materials, materials with higher recycled content and comparatively lower emissions are some examples for materials with lower embodied carbon emissions, right? So now this gives us a understanding on how glass can play in terms of reducing the operational carbon as well as the embodied carbon. So in order to reduce the embodied carbon of building, basically we need to use materials which are having lower embodied carbon. So with this understanding, let's try to understand what is the current carbon footprint of facades. So if you look at the a typical building, this is from a research reports, we have understood that in a building, facade, which includes glass as well as other materials like the system and the anchors and everything, contributes to 10 to 20% of the building's embodied carbon. And in that 10 to 20%, we had a a combined study done between Saint Gobain and Arup, and we did for 16 different types of glazing systems. And what we understood is, out of 10 to 20%, a glass embodied carbon can vary somewhere between 4 to 12%, which is a significantly higher number. And this calls for the importance of introduction of a low carbon glass, which can be available as an option for the builders so that they can reduce the embodied carbon of the building by using a glass which is having lower embodied carbon. So this brings us to the important aspect of of having a glass which is having lower embodied carbon. And with the Saint Gobain's mission of strongly decreasing the carbon footprint and also while maintaining same quality, performance, and aesthetics as our normal conventional clear glass, which is Planilux, and also available for the industrial scale, we present to you Ore India, which is India's first low carbon glass. And what is special in Ore India is basically Ore India is made with a higher recycled content. It has 70% of recycled content as a raw material itself, and it is made with a low emission fuel, which is LNG, liquid nitrogen gas. And also there has been a substantial R&D effort and excellent industrial teams to ensure that this Ore India looks like a normal glass, is strong and aesthetically similar to a normal glass, and also having the same amount of strength as that of a normal glass. The only difference that you have is that to produce this glass, there has been lesser carbon emissions as compared to a normal glass. To summarize, Ore India, to just give you some numbers, a 6 Ore India has 9.2 kilogram CO2 equivalent per square meter uh, is the embodied carbon, I would say. And this number is 54% lesser than the carbon footprint of a conventional or a normal clear glass. 54%. That's the number which we have achieved in Ore India, and which means that if this Ore India is used in place of a conventional clear glass, the facade's embodied carbon can be reduced by 30 to 40%. And the EPD for Ore India is under verification, and we should be having it available for public by in another maybe 3 to 4 weeks at max. And this number will be mentioned in that EPD, which can be also viewed or accessed by the public for verifying if the number is correct or not. So with Ore India, what we have achieved is a low what with Ore India, what you can achieve is you can reduce the embodied carbon of the facade as well as your building. It reduces the construction carbon footprint, and it also supports circular economy because 70% of the raw material is actually a recycled glass. It meets sustainability without compromising the performance. And we have a EPD which is going to come up, which validates that this has a 54% lower carbon emissions than a normal clear glass, and it is available in wide ranges. And it also can be combined with the our high performance selective coatings, which will further contribute in reducing the operational carbon of your building as well. And aesthetics, there is no difference. It looks same as that of a normal clear float glass, which is Planilux India. And this is a big step towards reaching the milestone of being a carbon neutral company by 2050. In fact, India has pledged to be a net zero by 2070. And this move in terms of adopting to low carbon materials is one of the key in reaching that milestone by 2050. And another important aspect to note here is about the sustainability goals that is being set by the organization, wherein the organization wants to become a carbon neutral company by 2050. And also we are in line with the measures that we are taking. And in fact, our emission measures have been validated by SBTI, which is Science Based Target Institute, which validates the emission measures which is being taken by the organization. So with this, I would like to conclude, and also I would like to summarize that we saw why it is important to decarbonize. We also understood what is the difference between embodied and operational, and how a building can become a net zero carbon by measuring, by reducing the operational carbon, and how glass can contribute in reducing the operational carbon. And we also understood about the embodied carbon of the glass, and discuss about ore and its benefits. Thank you, and I'm open for questions, Anvita.
Thank you, Mr. Avinash, for introducing us to low carbon glass. That is for sure going to pave a way for greener future. Your comprehensive presentation has provided us with the invaluable insights into the groundbreaking advancement, illustrating its potential to revolutionize the design and construction industry. We have learned so much from your presentation, and it has sparked even more curiosity today. So, to further the understandings, like you suggested, we would like to ask you a few questions.
Sure.
How does the use of low carbon glass affect the thermal performance and insulation of a building envelope with respect to different climates?
When it comes to use of low carbon glass in different climatic conditions, it's completely up to the, design of the building in those respective zones. But what I presented today was only the base glass. Like I was trying to compare repeatedly about the Ore India, which is a low carbon glass, versus a conventional clear glass. And what we can do on top of this is we can do high performance, high selective coatings, which are there with us, which is again what I explained in the operational carbon reduction, right? So those coatings, when done on the Ore India glass, what you will achieve is a building with a reduced embodied carbon, because Ore India has 54% lesser embodied carbon, and also reduced operational carbon depending on the type of coating that we are going to, or the type of product that we are going to choose. But other than this, with respect to different climate, there is no specific thing that I would be able to comment actually.
Understood. Wonderful.
Yeah.
So, how is the durability and lifespan of low carbon glass compared to the conventional glass products we all know in the industry? Are there
It
any
is
specific maintenance requirements or?
nothing. It is like I stressed upon, right? So one of the, I would say the best part of the innovation is generally when we try to come up with materials which are having lower emissions, the challenge is about maintaining the structural strength and also the aesthetics of the product. What we have achieved here is, so there is no specific additional maintenance required. The glass will look, in fact, I don't think even I'll be able to differentiate if I see a low carbon glass and a normal clear glass. That's how it appears. And there is no any special maintenance requirement for this glass. It is as good as a normal glass, just that it is lighter. When I say lighter, it's not in terms of weight, but in terms of how much carbon it's carrying inside, actually.
That's a very well, way to say that. So, moving on, are there any special installation techniques or considerations that the designers or the builders need to be aware of while they're working with low carbon glass compared to the other glass?
No, again, it's nothing. They can, specify it as a normal glass. Just that it has to be mentioned as Ore India. Other than that, except for the name and the lower embodied carbon, there will be no other difference in terms of thermal performance as well as the handling side.
Got it. So we are also kind of curious to know glass generally comes in different shapes and sizes, and people love to customize it according to their architectural requirements. So can we, as low carbon glass, be customized in respect to size, shape, color, tints, or finishes? Anything that we can do?
So when it comes to color, so like I mentioned, uh, the glass looks clear. So the low carbon glass looks like a normal clear glass. And depending on the type of high performance coatings that we, decide to have on the glass, we can obviously get some color, but it's again depends on the type of coating that we choose. But that's how you get the color part, or that's how you try to bring in some aesthetics to the low carbon glass. When it comes to size, it is available in standard sizes, which is 32102250 and 36602450, which is the standard size for a normal glasses also. There is no difference in this. We are treating this, or we want this to be a product which can be used by a lot of people for their project, so that we can play a part in the entire ecosystem in the decarbonization of built environment.
That's amazing. So this brings us to the last question for the day. We
Yeah.
know that you have an extensive experience working on green rated projects. Could you please run us through any or some of the recent green projects that use low carbon glass? It can be any notable architectural companies that you want to tell, or any other construction companies, for some inspiring examples or references for our audience.
So, I mean, I am right now kind of launching or introducing the low carbon glass to you. So, the market is also very nascent. There are cases where we have been discussing, and the discussion is going on. But we see that there are, I mean, to answer if there are any live examples or project demos, no, not yet. But there will be soon, because we see a lot of interest among the stakeholders about this product. And once we have the EPD also, which will be available in 2 to 3 weeks, we should be able to promote it more aggressively, and we'll be in a position where we'll have a lot of interest coming in. And when it comes to uh, references, yeah, we don't have. And in terms of adoption, so till now, like I explained, there a lot of emphasis has been on the reduction of the operational carbon, even in the lot of standards and codes. But we see a lot of upcoming revisions to the existing standards, where the emphasis has also been put on the embodied carbon reductions. So there is a rating or net zero carbon rating from IGBC, where they have given a threshold on the embodied carbon. There are upcoming ratings of lead, where they are also emphasizing on the embodied carbon. With all those coming up, I would say Saint Gobain is well ahead of the curve, and we have the product that is required to reduce the embodied carbon. And we only see the demand increasing rather than exponential way for this product, once we, along with the other bodies, create more awareness about this product.
That's amazing. So, we would like to once again thank you, Mr. Avinash, for sharing your expertise and inspiring us with this remarkable possibilities of low carbon glass. And this brings us to the end of our webinar today. So, all of us, all on behalf of all of us at Glass Academy and Ethos, we would deeply appreciate your valuable time and thank you for sharing your thoughts with us today.
Thank you, Amita. It's my pleasure, and thanks for giving me this opportunity to come and
Absolutely.
launch this special product with you.